Sarah Walker, and I'm from the SAGANet team, and I'm really excited that there's so many people online today for our first ever Mentor of the Month seminar. This is a new series that we're starting to really highlight our mentors on SAGANet. We have a lot of amazing early career scientists that have been very actively involved in our community and doing some amazing things with their science and their daily life, but also with engaging the public with our activities on SAGANet. And so this series is really meant to highlight the excellence of our mentors, both in their research and in their public engagement activities. So it's really up to the mentor to decide what feature of all of the comprehensive work that they do that they want to feature in their Mentor of the Month. And we are very fortunate and excited to have our first Mentor of the Month be Svetlana Shkolyar. She is going to be talking about some of her public engagement activities, developing teaching resources, and it's going to be a lot of fun. So I'm going to pass over to Svet now, and please take it away.
Hi, thanks. Okay, so let me go to the beginning.
Oh,
so is it recording or?
Yeah.
Okay.
Sorry, we need to do one thing here so everybody can see your slides. Okay, so we have the slides up and we are recording.
Okay.
Great.
Hi, thanks for coming, everybody. Okay, so what I'll be talking about today is a Space Grant Fellowship project, a NASA Space Grant Fellowship project in association with the NASA Space Grant Consortium here at ASU. Sorry? We're good? They can't see my slides. Okay. I think the 2D mix is not on.
I just
Is
turned
it on?
Oh, there we go. Okay.
Oh, perfect. Excellent. Okay. So this is a project from the NASA Arizona Space Grant Consortium. It's a fellowship. Space Grant also does internships for the undergrads, which are more research-based, and the fellowships for the fellows are have an educational component. So that's the project I'll be talking about today. So my project is basically trying to bring this idea of 21st century skills and just bring science alive in the classroom through this framework of astrobiology, of the question of, are we alone? Something that a lot of kids wonder, and yet isn't really incorporated into classroom science. And so, what if you could teach good science, good quality science in using next generation concepts and thinking skills and just the scientific framework for how we really do things, not cookbook labs or memorization, which is what a lot of kids associate science with. What if we could bring that into the classroom? That's sort of the basis of this project. And then I'll touch on a little bit on whether you're an educator or a student who's interested in helping out, how both of those groups of people can get involved. So first, I'll give a basic overview of the lessons, the topic, the structure, and then I'll briefly touch on how both students can help this mission by volunteering. Specifically, Space Grant interns are a good group, although they're not the only group of students who could be very useful in helping out, and also how educators, whether formal educators or informal, like after school or like, youth club type educators, can get involved in actually piloting the lesson materials and helping me with feedback. Okay, so let's jump into the lesson topics and structure. Whoops, sorry, there we go. So this all began actually when I first got to ASU about 4 years ago, and I started TAing, being a teaching assistant for an online course called Habitable Worlds, taught by this guy who many of you know, Ariel Anbar, who is in some ways sort of a pioneer in 21st century education. This course was innovative and unique in its own way. It is basically an online class. So it was GLG 106, so it's a 100-level science course for non-science majors here at ASU. So he used to call it a terminal science class. So this is like the last science class they'll be exposed to before they graduate and go on to their advanced careers. And, so his vision for a good introductory science class was to make it interactive, fun, and engaging, and to bring in real 21st century science into the general education college coursework. system. And so Habitable Worlds is basically an astrobiology class. So that encompasses what you see, these red words there. Astrobiology encompasses all of these topics. And I will go through the specific topics that are covered by both my lessons and, I guess, astrobiology as a whole in a couple slides. But what he did was make it a fun online module that walks students through all of these sciences and touches on each of these topics, from stars to solar systems, from the astro to the biology. And it was almost like a video game. So this course was designed by some folks here at ASU, namely Lev Hordisky, who is the course designer, and a company called Smart Sparrow, who is an education consulting firm. And they just put together a really great class where the students would go through these topics, and it would be like these online modules where every topic, planets, Earth, environments on Earth, life, would be like a standalone video game where the students would be led through a narrative and fun interactive tools and games, and there would always be some fun object at the end of it. It wasn't like what I call science cookbooks. Like, it wasn't one of those lab modules you're given where it's like, okay, follow these directions, do this with chemical A and then mix it with chemical B, and then in the end you should see this result, and then you should calculate this whatever formula, and this is what the outcome of your science lab would look like today. I don't think that's science education. I think that's teaching kids how to follow instructions. And that's not what science is about. And it's rarely, here's the end result, here's what you should expect, it should fit into this range of values. It's very much a discovery process of, I have no idea what I'm going to expect. Let's just create some hypotheses, test them, see what happens, and hopefully learn something out of it. To me, that's science learning. That's science. And that should be the way science is taught. And that was very much the way science was taught in Ariel's class. And so I took that and I thought, why can't we bring this Habitable Worlds model to the classroom, to the grade school classroom? Why should just the intro college students be learning this model of science? And the problem these days is that teachers are, they have standards, and they have to follow like very strict curricula based on what their schools define, based on what the state defines, and they're always stressing about the what are those tests called at the end of the school year, the state standards tests, and they're teaching it based on the curricula that came before them, which is old school textbooks and chalkboard learning, and the students have to read all this boring textbook stuff that is just a very outdated way of learning and doing science. Especially as we move into the 21st century, I think science education is lagging behind very much. So the problem is that teachers they know we're moving towards the digital age. They know this is technology and everything is moving forward, and yet, how do they find the time to go online, go out and find all these numerous, online, even NASA-endorsed educational products, and adapt them to their classroom, and figure out how to grade them, and figure out how to work them into their curriculum? The bottom line is that they lack the time to find engaging and reliable sources, and they don't necessarily know what's reliable, and they don't, even if they know it's a NASA-endorsed product, they still have trouble integrating it. That's what I've gathered from a lot of the teachers I've talked to, and so I thought this project is a good way to bridge that innovative model of 21st century science and help the teachers. So what I wanted to do with my project is, first of all, increase the teacher confidence in teaching these science concepts. Science teachers did not necessarily intend to become science teachers. Some of them are assigned science classrooms, and they don't feel comfortable teaching science content. And a lot of the time, they just do it the way it was always done before them, and they don't put any creativity into creating new and innovative and fun products. So I hope this project sort of makes them feel better, like it gives them a lesson packet with a framework that they can use to integrate these next generation concepts and teaching activities and methods into their curriculum. Number 2, supplementing classroom science with high-quality resources. I don't claim to like redefine the science curriculum or like reinvent the wheel or anything. The point is to supplement exactly that. It's a supplementation of what they're already doing. It's an enhancement of, it's a reinforcing of the science they're already learning in the classroom. Emphasizing key science skills. Yeah, like I said, I don't want this to be like a cookbook science curriculum. It's very much based on exploration and discussion-based activities and exploration-based activities, discovery-based learning and inquiry-based learning. Changing negative attitudes towards science. I think that's where it starts. You know, the reason why girls feel like they're bad in science and the reason why most people come out of school hating science is because of the way it was taught to them. It was because of the exposure they got to science, the very limited exposure they got in their classrooms, which was probably, you know, boring, textbook, memorization, regurgitation type science. So it's no wonder that kids have a bad attitude towards science. Teaching critical science strategies and real-world interdisciplinarity. Yeah, I mean, I think I've already touched on that enough. You know, we're moving into the 21st century where science is not only chemistry. You know, it's usually a mixture of multiple sciences. And I think that's very true, especially in astrobiology as a scientific discipline. You know, we are not one discipline scientists. We need to be well-versed in basic science and be able to translate through disciplines. And I think that's also something that's missing in the classroom. That is actually a very challenging aspect of this project because, you know, you're an 8th grade chemistry teacher. Where do you have time and space in your curriculum to integrate biochemistry or physical chemistry, you know? And so that's one of the challenges I face, and this is where I need feedback from the teachers to help me define what works and what doesn't in their classroom. So this is a very much evolving product. Increasing the number of students moving on to advanced STEM education. Yeah, I mean, that kind of goes along with changing bad attitudes in science. When you're inspiring kids from an early age, from a young age, that science is not memorization, science is not boring, science is not a cookbook, then maybe, who knows, 1 or 2 of those kids will go on to become, you know, big leaders and big thinkers in a changing world, and that's important. And it all starts with their education, younger in life. And but I shouldn't say that's the goal. The goal is not to like put this content into the classroom and produce scientists. That's not the goal. The goal is just to improve, you know, science literacy in general among the public and the next generation of thinkers who are going to grow up to, you know, make scientific decisions in their everyday life, from the food choices they make, the medical choices they make, the, you know, climate and sustainability decisions they make in their everyday lives. That all starts with a scientific framework of thinking. And so, you know, if this project at least helps improve science literacy a little bit, then that is partially accomplishing the goals there. So let's talk a little bit about the lessons themselves. There will be, when this is all developed, 8 lessons spanning the 8 themes of astrobiology, and I will get into what that means in a few slides. And it's basically a framework of the Drake equation, which many of you know has 7 topics, plus if you throw in an introductory, that's 8. So that's where that comes from. And each is very different. And like I said, we go from the astro to the biology. And so I'm in the process of developing content and lessons for each of those 8 right now. It's meant to be a both middle and high school set of lessons because you know, I went from taking a college 106 level course and developing it to the high school level and using a lot of the types of activities and links that we used from going from college to high school. So it's a little bit easier to go from that level to high school, and then from high school it's a little bit easier to go to the middle school level, and then going all the way down to elementary is quite challenging, but I'm actually in the process of doing that, and I think it's going to be a lot of fun to translate that all the way down to elementary level. As I mentioned, I'm not reinventing science. I'm not inventing a new curriculum from scratch. All I'm doing is taking what I think are high-quality educational resources from the NASA websites, the NOAA websites for, you know, like climate science, the EPA website for, water. For example, I have a water chemistry lesson. I'm taking these already developed materials, and all I'm doing is I'm structuring them in a way that teachers are comfortable teaching them, and I'm guiding the teachers through how to execute this, basically. And I'm providing this narrative that goes along with it. I give them like a blurb that they want to read to the class on, this is how you incorporate this into what you're already doing in your classroom with the standards that you're already teaching, and this is how lesson 1 connects to lesson 2, and get ready for lesson 3, because now you're going to take this concept and move it further. So I think that narrative is part of increasing the teacher confidence of teaching how to teach this more effectively. And yeah, it's really, my goal in creating these lessons is to take the guesswork for the teachers out of how to make a good scientific teaching lesson. And so I've incorporated all of these elements into it, so I guess I'll go through each of these. So the first thing there is misconceptions, and there's a reason why there's a little UFO icon next to it. It's because anytime you tell young students, we're going to think about life in the universe, we're going to think about astrobiology, the first thing that's going to pop into their mind is, are UFOs real? What about UFO sightings? And this is a great place to actually get started with this framework and introduce the scientific way of thinking, because the first lesson is actually an introductory lesson that introduces the scientific method, scientific way of thinking, and reproducibility is a big part of that. And that's one of the reasons why the scientific community does not usually dismisses the concept of UFOs. It's because rarely are they a reproducible phenomenon. And so that's a fun way to start that, with this framework of UFOs, and get the students interested. And not just in the first lesson, but anywhere where I can throw in something about misconceptions, I like to incorporate that in as like maybe a teacher's tip. Like, hey, if students ask about this concept, this is how you deal with it. The next part is exploration. Like I was saying, it's not about cookbook science. It's not about, let me give you the steps and you come up with a finished product, and your product should be some equation or some formula or something that fits in this range. It's a discovery-based process. And so a lot of the activities, I like to structure them like exploratory activities. Relevant connections to learners, that's a really fun one, because that's where you take this abstract, like stars, what are stars made of, types of concepts, and you bring them down into the everyday lives and like everyday pop culture, or for example news that the students are already aware of and exposed to. This can take many forms. There are, for example, astrobiology raps and videos out there that introduce astrobiology to kids. And even if it's a silly little song on YouTube, like a parody rap or something, kids like rap music. If they're engaged, I know it may sound silly, but it actually works. These little stupid 2-minute videos can get kids excited, and then they're not going to associate science with scary math or scary formulas and equations. They're going to associate it with, hey, that's something really cool because you can rap about it, which means I'll pay attention in class. And I actually have some links where I do have literally an astrobiology rap and a parody from Kesha's We Are Who We Are. That is an astrobiology introduction. And if we have time, I don't know if I should interrupt now, but if we have time, I will share those with you. And those videos are all actually extended activity links in Lesson 1, which is the intro. So the teachers can feel free to play all of this to their class. I also have a water chemistry song from the EPA website that I put in the water chemistry lesson. So anyway, if we have time, we can do all that later. The next thing is teacher tips. So I like to throw in this little red apple with a red logo teacher's tip somewhere, because it makes the teacher feel comfortable. I'm guiding them through, I'm giving them, hey, here are alternate ways you can teach this, or here's for example, I have vocabulary list, second to the last. That's a big part of each lesson. When you teach science, you inevitably teach jargon, so you have to provide the students with some sort of reference to what are all these, big words. Even astrobiology itself is a new word to a lot of students. So teacher tips would be something like, hey, you can do the vocabulary of this lesson as a homework assignment, or you can write the words on board, or you can give it to them as a printed reference sheet. It's completely up to the teacher, however they want to do it in their classroom. So teacher tips just gives multiple variations and tricks, so to say, to teaching these things better. The 5E learning principles. Yeah, so there are many teaching modalities out there, many ways of executing, the idea of teaching a concept. The 5E learning principle is something that I have been introduced to recently, actually, through someone I partnered with for this project, Dr. Jennifer Forrester, who is a SAGANet education consultant, and I believe she's now an administrator. Mm-hmm. And she is an education researcher herself and an expert in 21st century learning modalities. And so with her guidance, I decided to incorporate this idea of the 5E learning principles, because it's just a way of, it's a sequence of how to teach and how to learn, basically, using these 5 E's. I hope they're showing up clearly on the screen. Yeah, engage, explore, explain, extend, or sometimes it's elaborate, and then evaluate. And evaluate is placed in the middle there because that's kind of like, it's like a cyclic process of constantly evaluating as you go. And so this is endorsed by a lot of education researchers, and you see a lot of material out there that is taught in the 5E learning style. So where I can, I throw in those 5 E's and help the teachers just engage all of the different learner types in their classrooms through this method. Science standards, yeah, that's another huge one. So my educational partner with this project is Sherry Klug-Boonstra, who is ASU's Mars Education Program Director. They're out there in the Moore building in the basement, and they do a lot of amazing things with educators, not only in Arizona, but nationwide, actually. And they've won nationally recognized awards for bringing Mars science to the classroom. And so she's my partner, and she's been guiding me through this. Well, I guess I should say she's my mentor, and she's been guiding me through some of these aspects. And with her guidance, I've incorporated what are called the next generation science standards into every lesson. Science standards are big for teachers. They're not going to teach something that doesn't have a standard incorporated with it. And so I'm not trying to give them more work by incorporating more stuff into their curriculum. I'm taking the standards and I'm adapting my lessons to the standards that they should already be teaching. And at the beginning of every activity, I say, this stellar fusion lesson, for example, we're going to learn about how stars shine. And so this goes with like physics lesson, state standard lesson on atomic science and learning about binding energy. And so that is hopefully what the students will take out of this lesson. So I incorporate that into every activity. And there are multiple activities within the lessons, so that the science standards are a critical component. I kind of already went through the vocabulary list. Yeah, you got to have jargon, you got to have vocabulary. It's up to the teachers whether they want to integrate that as a critical component of the activity or just a reference component. And the last thing is rubrics. If you're going to have, educational material, you have to give teachers an idea of how to grade it. And also through Sherry's help, I've started working in these rubrics that are less about grades and more about learning styles. When you stop telling the kids you made a B+, then you're moving them away from, I got to get good grades, and it's all about making the A, because it's not. And I know I was this kind of student in high school. I was like, I got to make the A. It wasn't really about, I learned the concept at an A level. And the rubrics that a lot of educators are now adapting, and that I've started adapting with these lessons, is proficient, intermediate, beginner, novice. So you don't have this fear of grades, and the students are more likely to get something out of it besides, an A. So let's move on to the actual content. I mentioned this briefly. The framework and the reason why there are 8 lessons is because it's organized around what is called the Drake equation. And for those of you who aren't familiar with the Drake equation, I have a little video that is like what I was saying, the relevant learners to connections, relevant connections to learners. A little video that, here I have to go to the page. I hope you can hear it.
So you just have to make sure it's over the green box. Yeah, we can see it. I don't know if we'll be able to hear it though.
Contact with extraterrestrials by calculating the product of an
Sorry, let me.
increasingly restrictive series of fractional values, such as those stars with planets and those
Let's go
planets.
from the beginning. Okay.
Oh, really? Are you familiar with the Drake equation?
The one that estimates the odds of making contact with extraterrestrials by calculating the product of an increasingly restrictive series of fractional values, such as those stars with planets and those planets likely to develop life. N equals R times FP times NE times FL times FI times FC times L.
Yeah, that one.
So, for those of you who are familiar, that was the Big Bang Theory, and that was Sheldon giving his introduction to the Drake equation. And so that's another video that's provided as a relevant connection to learners in the intro lesson. Because kids watch the Big Bang Theory, and it's funny. I know I love the Big Bang Theory. So the Drake equation is, as Sheldon said, what do you say, a string of increasingly fuzzy terms that define, I don't even know what he said, but it's not really an equation for those who aren't familiar with the Drake equation. I call it a framework because it's a way of organizing astrobiology into a neat eight topic package. And this is the way it was taught in Ariel's Habitable Worlds class, through this framework of literally starting with the astro terms and then going to the biology terms. So going through each of these topics, they're really like probabilities. So the first is this variable n, which is basically the number of civilizations in our galaxy with which communication is possible. Now, that's not to say that's the point of astrobiology, and that's clearly not the point of my lesson package. That's just saying, again, it's a framework. Yes, it's a probability, but it's also just a fun way of organizing and framing this story of how do we even search? What do we even need to consider in the science of astrobiology to understand our universe and who else is out there? So N is like the intro term. Then we've got R star, which is the average rate of star formation. But again, that doesn't have to be exactly that. That's really stars. That's really the introduction to stars to the students. And then we move from stars to the planets that are orbiting those stars, the next component in habitable environments. And that's the term F sub P, which is the fraction of those stars which have planets. So then we consider the types of planets that are habitable. Then we consider N sub E, which is, I think this illustration defines it as the number of planets that then develop an ecosystem, but that's really another way of saying the number of planets that develop a habitable world. F sub I is the next term, and that's the fraction of those planets that actually do develop life. There's a difference between habitable environments and those habitable environments that then necessarily develop life. That's where we go from the astro to the geo, now to the biology. And then the last three terms are kind of a fun group of terms that are a little bit harder to teach, I'm not going to lie. A little bit harder to create lesson content around that is, part of the science curriculum. But I think it's fun, I think it's important, and I think it's critical to the story, and it's engaging to the students. So F sub I is not just life, but now we're considering that percentage of that life that then develops intelligence. And, you can do all sorts of things with that lesson. F sub C is communication, so that life that actually communicates. And then the last term is L, which is the lifetime. It's not enough to know that how would you know that there is intelligent communicating life out there unless it coexists in the same lifetime with you? So let me now talk about the content of each activity that goes with each of these lessons. I'm going to play my screen in slide share mode because, oops, oh no. Did it just crash?
No, No, we still have you.
You still have me. Oh, okay. I can't play my lessons and have... Okay. I think I'll just do this.
You can make the green box as big as the little screen.
Right. Sorry.
Sorry, it's kind of a cumbersome.
Can you see it now? Can you see it now? There we go. Okay, so in terms of lesson content, when we talk about N, this is, like I mentioned, the introductory lesson. So here's where I introduce the scientific method. Oh, you can't see the word method. Sorry, it's off of the screen. That's where we introduce the scientific method and go through the misconceptions concept and, the UFOs. The R-star term, the star term, is really where, right now, it's a lesson on stellar fusion and binding energies that can be developed in many other really fun activities. I'm kind of like a one-woman show, so, I'm still developing a lot of these things. So more activities on R-star are coming. F sub P, planets. Yeah, this is where, you teach the students basic planetary science, and that's part of many astronomy curricula. N sub E is the ecosystem or habitable worlds term. This is really the geosciences and a lot of earth sciences. This is a great place to learn water chemistry because, the reason H2O, H2O is a very special molecule. It's got a special polarity. It's got special... there's a reason why it's a universal solvent on our planet and why life uses it. And so this is just a fun way to introduce water chemistry through the concept of life on our planet uses water. This is what we mean when we say habitable world. Again, none of these are the only topic that can be taught in each of these components, but they're the ones that I have developed content for right now. Lesson 5 is F sub L, the life term. This is where we define life. Oh, it's cutting off the biosignatures, but this is where we introduce, what is an organism? Fire grows, organisms grow. Why is fire not alive? And this is a fun way to talk about detecting signatures of life, detecting biosignatures. And the activity I have for this one is this Mars analog experiment where they have 3 cups of soil, and I've added components to them that the students don't know what they are. One of them has yeast, and one of them has Alka-Seltzer. And when you add sugar water to both, they both bubble. And the third cup is like the control, nothing happens. And so the students are seeing this signature of life, which we introduce as metabolism. And one is a true signature and one is a false signature. So the whole idea is, they're making these observations and coming up with a little discussion-based, activity based on, which is the true and which is the false biosignature, and what are the limitations of this method. So that's a really fun one, and I've started piloting that one with younger kids, and the elementary schoolers, I think, would really benefit from something like this in the classroom. So I'm now adapting that to even younger. F sub I is it's the intelligent life term. So here is where a good place where we go into behavioral sciences and animal sciences. In the Hab Worlds class, this was also the where the idea of artificial intelligence was introduced and computer intelligence. So there are many ways you can have fun with the F sub I term and still integrate, like biology, animal sciences into that term. F sub C is one of the toughest one, and again, it's cutting off. I apologize. That's the communication term. I do not have content for this term yet. It's very challenging to find a way to teach communication as part of the astrobiology story. So if anyone has ideas, please let me know. In the Hab Worlds class, the last 3 terms, the intelligent life, the communication, and the lifetimes terms, they were all sort of grouped into this one little project that the students did where they developed a message to the intelligent civilization, and they had to take everything they had learned about, where their habitable world was, and I think they were given a chunk of the sky, and the whole semester they were given more and more clues as to how to find the life on their little habitable world. That was the way their class was done, and this was the finale. Now let's send a cute message. What would be your one message to this civilization? So I need to think more about how to put that into a middle or a high school or even elementary school curriculum. So I'm working on that one. And the lifetimes term. This is where you introduce sustainability. This is where you introduce the concepts of global warming, and you could even bring in social sciences into this and talk about, well, this is our only planet. We have to, how long is our civilization going to live, and when have we come close to almost annihilating ourselves? And let's think about, climate change and global warming, and then talk about the, repercussions that would have on our civilization. That's it for the lessons part. Now, the next topic I was going to move into is I'm going to undo this so that I can, whoops, let me bring it, okay. Now you can see the whole screen much more effectively. There are two vehicles I have for sharing my lessons with educators, because I need their feedback. The educators are kind of the critical component. I'm not in the classroom, so I have no idea what works with an 8th grade versus a 9th grade astronomy classroom, and obviously there would be differences there. So the first way I recruit more educators to come and test and give me feedback is through the many science festival activities we have on campus. Like, I have this screenshot of the Earth and Space Exploration Day, the ESC Day that we have here annually. There are a lot of similar events. We have ESC Day, that's one of the big ones. Recently we had Night of the Open Door. We have several times a month we have Open House, which is basically a department-wide, just sort of a smaller scale version of these festivals that's department-wide, and it's a family and public event where we set up all kinds of fun science demos done by the graduate students and the faculty and staff here at ASU in our department. And what I've started to do is I've put out flyers. We have an astrobiology booth where we talk about extreme life forms. We do some activities, and then they can make a microbe. And that is a great vehicle to just put up flyers for the parents out there that are, for example, homeschooling parents or educators themselves. And I get good feedback from them, and they pick up these flyers, and then they contact me, and so we have email communication about how they can get involved, and I end up emailing them content, and that's how we converse about the lessons I've developed so far. The other vehicle that recruits more teachers is, so Sherry, as I mentioned, my mentor through this fellowship project, that's her down there. She and the Mars Education Center here, they develop these twice a year conferences at ASU for teachers. They are a Saturday 9 to 4:30 conference, usually themed around something Mars related or very, very current in space sciences and Mars sciences. Like, for example, right after MSL landed, they did a big, Mars Science Laboratory, the rover that's on Mars. They did a big event on using the habitable environments that MSL was finding on Mars as a basis of Earth science activities for teachers. And it was all themed around MSL. The last one that they had this February, it was, hope you can read that, it was called the Maker Movement, which is an engineering framework for doing science in the curriculum that's become very popular recently. They had all these engineering and building type activities for students. And so these teachers are taking their Saturday to come to ASU for the entire day to learn how to teach more effectively and pick up all these free materials to then take back to their students. And they're not only Arizona teachers, they've actually come from 6 states and recently as far away as Mexico. So these are dedicated science teachers who were the science nerds when they were young, and now they're passionate about teaching and exposing their own students to all this fun science content. So they're a great group of educators to incorporate into my lesson activities as well. So I have a booth, and I do a short presentation, and they come see me at my booth during this workshop, and they pick up my lessons. I have both surveys and lessons printed out for them, so I have a sign-up list, and so that's how I basically recruit my own network through Sherry's network of teachers. The tough part, moving into the challenges, the toughest part is getting survey feedback from the teachers and keeping them engaged in the long term, because during this workshop they're kind of overwhelmed with like NASA science everywhere, and they're like, yeah, please give me NASA resources. Anywhere you stick that NASA meatball logo, teachers are so excited to just take everything you can give them and take it back to their students. But then when you follow up with them and ask them, well, have you had a chance to actually pilot this content? Have you had a chance to read this content? It's very challenging to get responses from them because, well, I guess survey responses in general are very, I guess in any sciences, right, there's always this issue with getting enough survey feedback. I've tried to say, hey, as a reward, I will Skype in with your classroom or demo these activities or come to your science night to pilot some of these activities with your school or with your class. Slowly but surely, I'm getting feedback. And the long-term engagement is an issue because, for example, oftentimes they switch subjects from year to year, or like one teacher would email me and say, no thanks, I don't need your content, and I haven't had a chance to pilot your content because I am now a Spanish teacher. Take me off your emailing list, please. And so, it's tough. Or when they switch schools, their email address changes. And so I lose a lot of teacher contact that way. And so, yeah, I would love to expose more teachers, not just because I need the survey feedback for metrics and for reporting purposes, but because the more teachers I can expose to this, the more students I'm indirectly exposing to this content. And I think that's really the bigger mission, to get as many kids into this as possible. And yeah, I'm a one-woman show here, so that's why I love recruiting students, especially space grant interns, because, and that's the topic of my next section, how students can get involved to help me. So there are plenty of opportunities for all sorts of students to get involved. Mainly the group I've worked with in the past have been space grant interns because at the undergraduate level, the interns do a research-based project, but they are required to do 10 hours of volunteer work on some educational component as an agreement through their internship and their stipend. And that's a great way to get their 10 hours to help me, develop my content and edit materials and help me create new materials and help me scan all the resources and find the one that they think is the most fun for, this particular topic, or link standards with some content that I've already found. So there are many, many ways that interns can help, and even if they're interested in having the face-to-face component with the students themselves, because a lot of them are interested in interacting with the kids. There are plenty of opportunities that we can create for that to happen too. So if there are any space grant interns interested, please contact me, and I think a few of them are already on SAGANet listening, so thank you for coming, and we can chat later about how you guys can get involved. And yeah, this looks great on any CV, not just for an intern, but for example, astrobiology enthusiasts and education students, if you're looking to not only master the concepts of astrobiology, but master classroom design concepts, or master science standards concepts and get experience with how to incorporate science standards into some curriculum. These are great opportunities for students to work with me. Astrobiology students, some of whom go on to become professors and faculty, this is a great way to get experience with course content. It's almost like another way of being a teaching assistant through the classroom content side. And yeah, remote participants, that's, you're not you don't have to be here, because obviously the whole point of this is that we're in the 21st century and we're moving towards next generation science thinking, and so this is a great way for remote participants to get experiences with the same things, course materials, master the basics of the science, get some nice experience for your CV, whatever your reasons are. I mean, if you want to help, please contact me. There, we can figure out something. And yeah, if you are an educator, or if you know a network of educators, whether formal or informal, there's plenty of room for you to be involved in this as well. Not only middle and high school teachers, but like I have here in the little asterisk, any level really. I would love your feedback, because like I said, if I'm developing this for the younger the elementary levels, this is a great way for you to help me with that. And not just teachers, but homeschooling parents. I found they're a great crowd to do this beta testing with, because they are less restricted by state standards and curricula, and the principal at my school says we only have to do it this way, but we can't do it that way. And they're very, very open to creative learning and creative thinking with their learners, so they're a great group that I'm trying to recruit more of. And informal educators, youth clubs, like YMCA type programs, after school daycare center programs. There are plenty of opportunities to do like a 1 hour little science activity, and the majority of these activities can fit into that time frame. So you can pick and choose sub-activities within a lesson to do in an informal situation. So I'd love to hear from more informal educators as well. And this is a little picture of my survey that is online and that I give out to anyone who takes my materials. And I'm always looking for feedback. So if you know of any teachers, send them my way. And finally, the near future, I would like to accomplish 3 major things. So the first is that I'm always increasing my teacher network. So that's my little network logo there. I think by increasing the number of teachers exposed, whether or not they give me the survey feedback, preferably if they do, so I can have something to tell, my higher-ups at Space Grant at NASA, hey, this is working, and I have anecdotal evidence from my teachers. But even without that, it's still, that's still the mission there, to increase the number of teachers and students exposed to this STEM, science, technology, engineering, and math content. And the next thing is the last 4 terms, the intelligence, communication, and lifetime terms of the Drake equation. The last 4 of the 8, basically, those have not been developed yet, and I'm working on more content and ways to bring that into the science classroom. So that's what I'll be doing in the near future, and anyone who wants to help out can have a very prominent role in helping me develop those 4 topics, which I think are arguably the most fun 4 topics. And SAGANet. So a lot of really exciting things are going on with SAGANet, which, for those of you who don't know, is this basically online astrobiologist network community headed by Sarah Walker and several other people, and Sanjoy, Som, and a couple others who may or may not be watching, I'm not sure. Julia. And Julia DeMarine and Grasshopper. And so these were some of the founders of this really, really awesome astrobiology network website, which in its 3 or so years of existence.
Yeah, we launched in April in 2012.
Yeah. So several years of existence has become this amazing network with I don't know how many people you have on there now. I forget.
Over 1,200.
1,200. There you go. So and they've done all these different components, from like reading groups to broadcasted seminars to mentoring and educational components on the website. So I'm really excited to get involved in the educational side and create an actual platform through SAGANet to host my lesson content and my surveys. So that's sort of what's coming next. And stay tuned because my content will go live on Sagan in the near future. So I'm excited about that. And that's basically it for me. If you have anyone you'd like to get involved, or if you yourself want to get involved as an educator or as a volunteer, feel free to contact me. And thank you for listening.
So, online audience can ask questions at this point. They've all been chatting and very excited.
Nice. Oh, yay. I also have the fun links if anyone wants to see the AstroBio wrap or the water movie.
There was some clamor for watching some of the videos.
Excellent. Should we take questions, or do you want me to play let me know.
Well, let's play the video, and then people can come up with questions, and I'll ask afterward, I think, now that we...
Cool.
So please ask questions, guys. That was a great talk.
So, yay, thank you. So I have several fun links. One of them is an introduction to astrobiology through this. I don't remember his name, but he's a British guy. And
I remember him.
Do you know this guy? He was
I forgot his name too, but he was at AbGradCon many years
was he?
back. Yeah.
Oh, because he was at this conference for intelligent life, the societal impacts of intelligent life that I actually went to with Mark in London. And they endorsed his video, his little astrobiology wrap at the conference. And you can see here, it's endorsed by the Astrobiology Magazine European edition. So this isn't just, junk that's out there made by some guy. This is...
Yeah. This was AbGradCon 2009. That's
thank you.
In there. It was
nice. Yeah, I mean, I don't know if he does science songs for a living, or what does he do?
Julia's got it.
Nice. Thank you, Julia. And the other one is a parody of Kesha's We Are Who We Are. It's an astrobiology parody. And then the third video I have is this water cycle wrap. This is part of the water chemistry lesson. So I can play any of these or all of these, whatever we have time for.
Well, yeah. Whichever one. What do you think? Do we have votes from the online audience?
Yeah, let's have votes from the online audience.
So Sandra's asked a question while they're weighing in their thoughts. He says, what's the biggest challenge? Is it content distribution, content building, or something else?
Something started playing. Sorry. Oops. Okay. Content distribution. I'm sorry. What's
the biggest challenge for you, basically, with this whole project? Because this is a huge undertaking, so you have a lot of challenges. Is there one that's really...
It's not so much the content. I think that just takes time. That's not so much the challenge, because through the Habitable Worlds course that I TA, I got exposed to so much content. So I've got more content than I know what to do with. It's just executing the content and getting it out to teachers and getting them to report back to me what works and doesn't in the classroom. Because in my head, I'm in a research lab, and I have these ideas for how this content should look in a classroom, but like I said, I don't interact with the students themselves. So I think it's really challenging to know, for example, teachers do and don't have certain facilities. I was shocked to hear that some teachers were telling me they don't have access to printers, or they don't have a lot of computer lab time, or there aren't enough computers for every student. They have to do group work. So tailoring the activities to these restrictive environments and even underserved populations at some of these, for example, Title I schools, I think that is the challenging part.
Wow. I know, I find it always shocking when you're a scientist interested in doing public engagement, how little you know about what the public's needs actually are until you start digging into it.
Exactly.
And that's one of the biggest hurdles, I think.
And that's why I'm always so, almost to the point of begging and bribing the teachers, please fill out the survey. I need to know.
No, it's good you're getting quantitative feedback like that.
Mm-hmm.
So there's a general consensus, I think, that no one has seen the water video. So we'd like to see that one.
Okay.
And then there's some awesomeness about Julia making her own rap videos.
Oh, yes. Okay.
Which we all agree she should do.
It's hard to... There we go. Sorry, it's...
The movement of water, my purpose get on above the below the surface in the continuous cycle. My work's never done, cause I'm driven by energy. from the sun. I travel through the sea, through the air, through the ground. You can say that water really gets around, but in fact most water's just chilling in the oceans. Only a small fraction is really in motion at any given time, but yo, that's the way it goes. When we're studying the voyages of H2O, in the cycle water changes states at various places of 3 states being ice, liquid, and water vapor. But this type of strange from the norm, cause through the process water still keeps the same structure form. While the cycles involved chemical change, water may change states, but its structure stays the same. To the sky, from the sea below, day down to the ground is rain, snow. Watch me go rain, water cycle, rain, water cycle. To the sky, from the sea below, day down to the ground is rain, snow. Watch me go rain, water cycle, rain, water cycle. When water transforms from liquid to gas and rises up into the atmosphere, that's evaporation, a process made possible by energy from the sun, also known as solar radiation. And when there's water vapor in the sky, reforms into liquid water droplets, that's condensation. And when the water falls back down to the earth, there's rain, snow, hail, or sleet, that's precipitation. Plants have their own type of evaporation through their stomata, which is called transpiration, though collectively the term used for transpiration. Plus all other evaporation is evaporation. 2 more terms to add to your collection. The movement of water through the air is convection, and speaking of keeping it moving, understand that runoff is water flowing across the land. To the sky, from the sea below, day down to the ground is rain, snow. Watch me go rain, cycle, rain, cycle. To the sky, from the sea below, day down to the ground is rain, snow. Watch me go rain, cycle, rain, cycle.
I just want to point out that this video, again, it's not just junk that was made by somebody out there. This is from a website called TeacherTube. For those of you who are not familiar, this is basically YouTube for educational purposes. In many classrooms, teachers are not allowed to use YouTube because of all the junk content out there. But TeacherTube is a way to migrate many of the good quality videos endorsed by teachers to a platform where teachers can play this in the classroom, and it's not usually blocked. So this is a video from TeacherTube, and this is again part of my Habitable Worlds water chemistry lesson. So.
That's great. I didn't know TeacherTube existed. That's awesome.
Yeah.
So we have a question from Graham,
Uh-huh.
and he says he's had a lot of issues with missed and lost connections with educators and parents in building his mentoring/teaching network. What would you say is the key to maintaining your network?
Yeah, that's a challenge. Yeah, like I was saying, I have issues with lost communication too, and I basically have to just stay persistent and just constantly email update. That's why I'm really excited about getting a platform through SAGANet, because right now I'm just basically sending email updates to the teachers like, hey, have you thought about my lessons in the last 6 months? Hey, it's break time almost. Do you have any content for like when you finish one lesson and before you start another? Or have you considered like a day or two of some fun activities? Well, guess what? My lessons could constitute that transition between a break and a next activity. Have you thought about it? Well, let me know if you have feedback. So that's kind of how I have to be with the teachers. And yeah, sorry, is the question how do I deal with that, or if I experience that?
What's the key to maintaining your network?
Oh, I guess I can't do anything if the teacher's email address or whatever becomes inactive or if they stop responding, but I think continuously expanding the network is the key to that, and that's why I'm always recruiting with my flyers at the Exploration Science Day events and open house events on campus. It's having my teachers be aware and having them take flyers or whatever by word of mouth, spread this to their teacher contacts at their schools, because I've had a lot of that happen. And homeschooling communities are actually they're very good networks of communities, and I think that the homeschoolers have to by default keep in contact more so than classroom teachers, because they're so dispersed and remote, and they don't have a set way of doing anything. So they are a great online network, and they share some of my content in their own networks. So I think just constantly expanding is the way to deal with it.
That's great advice. So Sanjoy has another question. He says, do you get negative views from colleagues about you taking too much time to do outreach and not enough on your research? And how does outreach benefit your science?
Yeah, that's a great question. Thankfully, no. Thankfully, I'm lucky enough that my research advisor, Jack Farmer, I think he really supports this, and he himself is very big in the public education sector, and I think he views it as a critical component, and I think all of my science mentors have viewed it as a critical science component. In fact, I did a NASA Academy internship a little while ago, which is very 6 years ago, which is one of the highly ranked NASA internship systems out there, and I came in as an astronomy education intern. My whole project during that summer was astronomy education for Girl Scouts, getting them a badge on getting them a Girl Scout badge through some astronomy-related events where they spend the night at the museum and then fulfill their duties to get this science patch. And so, I mean, I guess I've always been exposed to this education component, and I've always thought that, for example, the mentor I worked with on this NASA Academy project was an astronomy researcher at NASA Goddard, and she had some grant money to do education on the side. So I think it's not negatively looked upon at all. I think it's very positive that you can become a scientist who is able to obtain funding from an educational organization, an educational funding organization like NSF or even through NASA. I think that makes a scientist much more versatile and much more able to, stay permanent and keep funding in hard times. And in terms of how it benefits my research, I mean, I guess that's just the funnest part of the job, telling people, oh, hey, I think about life on Mars for a living, and I work with instruments that may be on Mars one day, and we'll be doing this kind of science remotely on another planet, and that really engages the public, especially young kids. So I just think it's a fun part of the job.
Yeah, well, you're getting a lot of rock on.
Yeah,
thanks. Keep up the awesome work. Okay, so I think we're at time, but Svet is on SAGANet, so if anybody that's listening has follow-up questions for her, you can find her, and she's also got her email up on the screen. And thank you, Svet, for giving us such an excellent kickoff to our Mentor of the Month series.
Sure, thanks for having me.
Great. Thanks, everybody.